Hello and welcome to another example of learning about solving systems of equations using the substitution method. So I'm glad you're with us. We're going over the substitution method. I've got more of a difficult example here, but here's the steps we're going to run through. We're going to learn how to isolate the variable. Substitution method involves taking one of these equations, these are two linear equations, and we're trying to find what that intersection point is. What is that x and y value that makes one and the other equation true? So we got two equations, we got two things we need to satisfy, and essentially if I graph these two, I'm just trying to find that intersection point. Okay, so let's use the substitution method here. Well, first step is to get a variable isolate one of the variables. What that means is I want to either have x all by itself on an equation or y all by itself on one side of the equation, or whatever variables I'm using, whatever system I have. In this case, I don't have anything set up nicely, so I have a little bit of work to do to be able to use the substitution method. So now I look at, well, which equation is it easiest to get a variable by itself? This first equation, I've got x buried in the parentheses, y is being added to 12 and multiplied by 8. That one is not friendly looking at all. However, the second one, I have a 2x, I have a minus y. It's not too much of a stretch to add y to both sides, subtract 20 from both sides, and rearrange this whole equation to turn it into y equals 2x minus 20. So I'm just using some algebra, I'm rearranging some things around, and it only took a couple steps, but now I have my y variable isolated, and I can see that y is equal to 2x minus 20. So there we go. We just did step one. We isolated the variable. I got one of my variables by itself. And what does that let me do? It lets me take everything that y equals and substitute it, put that 2x minus 20 in place of y in the other equation. So I'm trying to combine essentially all the criteria for both equations into one equation, and I use substitution to get that done. All right, let's look at what my new equation is then. So I still got 4 times x minus 1 is equal to 8, but instead of 8 times y, we're substituting 2x minus 20 in place of that y. So there we got 8 times y, or 8 times 2x minus 20, but I still got the plus 12 at the end. All right, we've just substituted my equations together, and now we're ready for step 3. I've got one equation, I've got an equal sign, x is the only variable left, so I'm going to solve this thing out for x now. All right, so let's do some distribution. I have two sets of parentheses in here, so we'll distribute the 4 to get 4x minus 4, and we'll distribute the 8 to get 16x minus 160, and this we got plus 12. All right, let's simplify some things. Let's combine some like terms here. 4x minus 4 equals 16x. The negative 160 plus 12, if I add those two together, we get negative 148. All right, this is looking a little bit nicer. I still got x's on both sides, so I'm going to subtract 4x from both sides. Combine 1 to get 1x over there. That's going to turn to 0. But I'm also going to go ahead and add 148 to both sides. I'm going to move that 148 to the other side. So now we've got that turning into 0. 16x minus 4x is going to leave me with 12x on the right. Once all that settles, the 148, all those canceled out. But on the left side of the equation sign, now I've got negative 4 plus 148 is going to be 144. All right, my final step is now to divide both sides by 12. The opposite of dividing by 12, multiplying by 12, those divide out. And it looks like we get x is equal to 12. 144 divided by 12 is 12. We just found part of the solution. We just solved for one of the variables. So if I was to graph these lines, if I'm thinking about which point, which x and y value make both these equations true, we just have seen that the x value when x is 12, that's part of my solution. I still have to find the y value. I still need to know, well, if x is 12, it's a relationship. So what is the y value when x is 12? That's what we got to find next. Now we're going to back substitute. I know x is 12, so I'm going to put 12 in for the bottom one. This second equation right here, the 2x minus y equals 20, that's to me seems the easiest equation that then solve for y. So let's put 12 in for x, and let's see what we got. So 2 times 12, because I know x is 12, so we got 2 times x minus whatever y is should equal 20. So we just back substituted. Now let's solve for the other variable. I'm going to draw my line down. Let's solve for y. 2 times 12 is 24 minus y equals 20. Let's subtract 24 from both sides. 24 goes to 0, so we got negative y equals 20 minus 24 is negative 4, which means divide both sides by negative 1, that y should equal positive 4. All right, so if x is 12, then y is 4, and we just solve for the other variable. That should be the solution, right? If I put x is 12 and y is 4 in for both equations, both of them should work out. We know it will for the bottom one, because we used the bottom one to find y. But now let's check our work by putting it into the top one. So I'm going to put x and y in place here. Does 4 times x, which is 12 minus 1, does that equal 8 times y, which we saw is 4 plus 12? We're going to check our work out. Well, 12 minus 1 is 11. And 4 times 11 is 44. So on the left side you get 44. Let's see if all that works out on the right side. 8 times 4 is 32 plus 12. 32 plus 12 is 44. Yes, I love it. Things check out. And we just found our solution. When x is 12, y is 4, that is the point of intersection. It's the point that satisfies both of these equations in my linear system.